Hello community, we propose human Gaussian graph, learning generalizable and animatable human Gaussians from videos. This work addresses the challenge in modeling generalizable Gaussians from a video. We introduce human Gaussian graph to model the connection between predicted Gaussians and human SMPL mesh so that we can leverage information from all frames to recover an animatable human Gaussian representation. Our method takes in a video input of a human and outputs an animatable human avatar which can be driven by pose parameters. For a video input, we first generate multi-view images for each frame in the input video with a multi-view diffusion model. Then, for each frame with multi-views, we utilize a Gaussian reconstruction model to produce Gaussians for each frame. Different frames are discerned with colors. Then, we build our core module, human Gaussian graph, on the predicted Gaussians. Specifically, as denoted in the large circle, our human Gaussian graph is composed of two layers, SMPL mesh vertices and the predicted Gaussians. Connections between the SMPL vertices are decided by the mesh structure, and the Gaussians in each frame are connected to the nearest mesh vertex, forming a graph modeling all Gaussians across temporal axes. On the graph architecture, we further propose two types of operations to cater to the temporal and spatial integration, respectively. As denoted in the pink edges, an intra-node transformer is proposed to gather information from all Gaussians from different frames to the SMPL vertex, and inter-node transformer is used to pass information in nearby SMPL vertices. Thus, the SMPL vertex features integrates information from both the temporal and spatial axes. After that, one frame is selected as a basis for final Gaussians. Their features query the SMPL vertex features and get updated. They are bounded to the SMPL, forming an animatable avatar which can be driven by pose parameters. This is the overall method of our learning generalizable and animatable human Gaussians from video. We present the experiment results. We configure the reconstructed human avatars to unseen poses, and we orbit the camera around it to form the views. The avatar can be driven by SMPL pose parameters. We also provide results for novel view synthesis. For scene poses, we just orbit the camera around it and see different views. These are more experiment results. Comparison with other methods show that our human avatar is better in overall quality and details like face, hands, and arms. This demonstrates the effectiveness of our proposed human Gaussian graph. Thank you for watching.